actually get there. So the first thing I wanted to do, sorry, I'm just arranging my windows here, is review homework 1. All right, so let's do that. Go to our studio. All right, so this is homework 1. I'm not going to go through creating the 3 figures that I asked you to create. So I said, right, the primary parts were use at least 3 mutating joins, use at least 1 filtering join, and produce at least 3 data displays. So I'm only going to show you 1 data display. It's not the most amazing plot ever, but it's an example where I actually helped a student with this last year, where she was trying to do something, and then we ended up using a semi-join to help do what she was wanting to do. So, so I'm going to illustrate 1 that way to illustrate semi-joins, but then I'm going to actually show you a real-life example of a semi-join that's in this other script over here, which is actually part of the scripts that I run to generate the website. Okay, so we'll go through that as well, but mostly I'm going to be focusing on the joins, and then I'll walk you through the code to reproduce the plot and to create the plot that was extra credit. Okay, so starting out, load the tidyverse, set the theme. All I'm doing is just setting the plot title position to plot. Then I'll read in the data. I'm only going to read in 4 of the data sets here. So student assessment data, student info, the assessments data, and then the registration data. All right. So then the first thing I need to do with these is identify the keys. All right. And this can be quite tricky because in some cases it's pretty obvious, but in other cases it's not. These data sets all do have keys though. So so that's important to keep in mind. And actually, if we look at that help documentation that I linked to, it has a little icon that tells you what the key is for each table. So if you did your homework that way and studied the actual data documentation, you would have had the keys that way. Okay, so for assessments, we can check the key by just saying count ID assessments, ID assessment, which is what I'm sort of guessing is the key, and then filter where n is greater than 1, right? So if this is the key, this should return a table with 0 rows. So in other words, ID assessment is each ID assessment value is only represented 1 time, okay? And if that's not the case, if this returns even 1 row, then you know that's not the key, or you have an error in your key, okay? That should always return 0 rows if that is the key. For the second one, for student assess, you might think it's ID student, but it's actually not. ID student repeats. We have multiple rows for each student, and that's because each student took multiple assessments. So the key is a combination of ID student and ID assessment, and we can verify that. It takes a little bit longer because the data set's a bit bigger. Okay, so again, we end up here. For student info, we have ID student, code module, and code presentation. So again, if you were working on this, this might have taken you a little bit more time to guess ID student and then maybe guess ID student and code module, and it's still not there. So then eventually you end up settling on ID student, code module, code presentation, and you can see that returns a table of 0 rows. Okay, so now for 3 of these data sets anyway, we have the keys. It's ID assessment for the assessments data set. It's ID student and ID assessment for the student assessment data set. And it's ID student, code module, and code presentation for the student info data set. Does that make sense? Any questions on that? Okay, now moving forward, we want to do some joins with these, right? But again, the really important part is that we don't end up in a situation where we have a many-to-many join. We can have a one-to-one join or a one-to-many join, and those are totally fine, commonplace, normal, what we're doing all the time, right? But a many-to-many join is not something we want because you end up with that Cartesian product of each, basically every combination of the multiple keys. Okay, so you start out with one data set that has, say, 1,000 rows and another one that has, say, 700 rows, and you do a many-to-many join, and you end up with a data set that has, you know, whatever, 12,000 rows or something like that. And if you end up in that situation, that's a really good key to you that you've probably conducted a many-to-many join. All right. So here, I am actually not even going to specify the keys, because the keys will dplyr will find the keys by default, but it will print them out for me so I can verify. All right. So I'm going to left join student assessment data with the assessment data. And when I do that, I get my output down here. But if you scroll up, you can see it says joining by ID assessment. That's great, right? ID assessment does not uniquely define rows in stu assess, but it does in assessment. So that's a one-to-many join, and we're good. All right. But the thing is, now I have a new data set, right? And so now I have to go through this process again of verifying what the key is for this data set, because just because ID assessment worked for this join doesn't mean it'll work on the next join, right? I need to know what the key is on this one, because sometimes those keys can get messed up, and now it's the combination of 3 variables instead of 2 variables or whatever. Okay, so I'm just going to verify that it is the same that it was when I had stu assess. Okay, so it should still be, in this case, it should still be ID student and ID assessment, but I'm just going to verify that. Okay, so I'm going to count both of those variables after the join, and then filter where n is greater than 1. And you can see it joined by ID assessment, and then it did this count and filter, and we end up with 0 rows. So this joined data set has the same key as stu assess, right? It's those 2 variables, ID student and ID assessment. All right. So there's one join, but now I can actually just pass that straight to stu info. And when we do that, you'll see the first one joins by ID assessment, and the second one joins by ID student, code module, and code presentation, right? And I can only do that, actually, I can only do this second join because of that first join, right? Because I don't think I had code module and code presentation in there until after joining it with assessment. All right, so you have to do these things in the correct order to get your keys lined up so that the joins all work. Okay, so there's 2 joins that I've done now. And notice I can verify that this is correct because I know within stu info, as I did above, these 3 uniquely defined rows, which means I am in at least a one-to-many join, if not a one-to-one join. Okay, and I think it actually is a one-to-one join at that point. Any questions on that? Okay, then the last part is I just need to do one more join, right? So I read in the registration data, which has some data about when the student registered relative to when the code module started. And so it's a bunch of negative values if it's days before, and then the day they unregistered, which they either completed the module or they unregistered. So if it's NAs for everybody except for the people who dropped out, and then those have specific days. So if there was something we wanted to do with the people that dropped out, then we might want to know how long they were in the code module, right? So I have this data, it looks like this, right? As I said, negative values and positive values over here, but a bunch of NAs. Everybody who's NA finished the code module, right? So just looking at this, I'm going to guess it's probably these same 3 that we had for stu info. So I'll check that, and it is. So now I can just left join that here, right? And it says it's going to join by those 3, and I'm good to go. All right. Any questions on that? Okay, so this was super open-ended. Please do look at the feedback that I'm giving you. I'm trying to give you all as much feedback as possible. When I am removing points, I'm trying to walk you through exactly why. So try to please look at the feedback that I'm giving you. I won't hardly ever give you a score without giving you feedback, all right? Okay, so anti-join example. So let's imagine now we're in a situation where we want to look at the distributions of time elapsed between the date the assessment was taken and the date it was submitted. And we want to look at that relation by code module, okay? So we're just going to look at distributions. So first, note there's many students who took multiple code modules. So if we just count code module and ID student, we get a bunch of 5s, right? So we can't just look at these distributions from the get-go. We need to, because we're trying to look at it by student. So instead, I'm going to compute the average for each student. Okay, so first I'm going to compute the date difference, right? The difference between the date submitted and the date. Then I'm going to group by ID student and code module and just compute the mean difference. Okay, so I'm calling this sub by code, and it just looks like this. Okay, so here's the student, here's the code module, and here's their average date difference. Okay, then we're going to plot these distributions. So this is pretty straightforward, right? But I end up with something that looks like this, right? And this is like not very helpful, right? And in large part, it's because most people are submitting, like for most people, the date diff is right around 0. Okay, and so that makes some sense, but it also makes it difficult to see the rest of the distribution, right? So what we're going to do is we're going to take this and we're just going to filter where this is greater than -10 and less than 10. So anything that's within 10 minutes. Okay. So we take this, I'm calling it cases to remove. Okay, so here's a whole data set, and this is all these big spikes, basically, right? And now I'm going to remove those data sets, or those cases, from the data set, so I can plot this again and basically plot the exact same distribution, but with that slice of the data removed. Does that make sense? So here I have sub by code, my full data set, and I'm going to anti-join it with cases to remove. Okay, now I have only the data that is outside of that 10-minute window around 0. Okay, now when I plot it, I get something that looks like this. Notice here it's still pretty hard to see, but this distribution is much easier to see, as is this one. We could free up the y-axis, and that would make it easier to see those other ones as well. But it's probably, I mean, it depends on what our purpose is, but often it's good to keep your y-axis consistent. Okay, so you can see you just have this little, like one of the bars removed, basically, which is that one right around 0. Okay, there's other examples of this that we could do too. What I'd like to do before we move on to the last part, well, first, are there questions on any of that or comments? Okay, I'd like to walk you through now a real example. Okay, so this is actually a fairly classic example of what I do a lot, which is take a task that takes 10 seconds and but you have to do it manually each time and spend an hour on it so that I don't have to spend those 10 seconds anymore, which is really dumb, but it's what I do. So so this is a script to basically look into my slides directory and see if a PDF is there for the slides, and also check if that PDF is out of date, okay, out of date with the RMD. And if it is, then it will regenerate the PDF, okay? So but the reason I'm showing you this, right, is because I want to show you a couple of real examples of both semi-join and anti-join, okay? So what I'm doing here, this is more code that I don't really care to explain too much, but it's basically looking in that directory, giving me some information on it, and then pulling just a few specific things. So if I look at RMDs, this is the path for every R markdown file in my slides, right? And this is the week that the RMD is for, okay? And there's 4 more rows here. Then I have the same thing for HTML. So I have my RMDs and I have my HTMLs, okay? And then I have the same thing for PDFs. So now I'm looking at, now I have RMDs, HTML, and PDF, right? Those are the 3 file types for the slides, basically. But what I want to do is say, okay, well, maybe because if we scroll down here, right, you'll see later when I get down here, we have like week 7, part 1, part 2, 8, part 2. These are ones that I haven't updated yet. So these are the old slides. Okay. So if I say anti-join the RMDs with the PDFs, that will give me then all of the RMDs that do not have a PDF currently. All right. So if I do that right now, you will see I get nothing because everything is up to date. So what I'm going to do is actually drop a file in there for week 7, part 2. Okay, so you can see it just showed up right here, right? And now when I run this, well, I'll have to run the other stuff first because I need these things to regenerate. All right, now when I run this, I get week 7, part 2, right? Because week 7, part 2 has an RMD, but it doesn't have a PDF. And so that's what that anti-join is giving me. And that's a very programmatic way to do it, right? I never have to check this manually by some filter or whatever. So, okay, that has no PDF. Now let's actually open up this RMD and let's say we're going to make some edits or whatever. And then I'm going to try to knit it. I actually don't know if this will even knit. I haven't tried it yet. Yes, it looks like it did. Good. Okay, so now I have an HTML file, so that's great. I need to regenerate this stuff real quick. But then down here, so I have this no PDFs. I'm going to get the week 7, part 2 doesn't have a PDF, right? But now I'm going to my PDFs thing, right? This is still all the PDFs, and HTML is all the HTML files. So what I want to do is find those HTML files that are out of date, okay, with the PDFs. So this is actually not taking into account yet those ones that don't have one. So I'm going to anti-join PDFs with HTML, and notice I'm joining it by week, which is this part, week 1, part 2, W1 part, whatever. And then the modification time. And the modification time I rounded to the nearest minute. Okay. So if they're out of date by more than 1 minute, then they will pop out here. Okay. So I'm going to anti-join those. And notice I get week 1, part 1. And this is because there's a weird error in week 1, part 1 that I can't generate the PDF from it. So, okay. So that's the only one. Now I'm going to semi-join all of my RMDs with this thing that I just had here by week. All right. And that's going to give me now this one, which is still just week 1, part 1. Finally, I'm going to drop week 1, part 1 because I already have that PDF. So now I have nothing, and I'm going to bind rows with no PDF, which gives me that last one. Okay. So now I have this object that's to print. And this is just the PDFs I need to generate. And then I'll do this, which will walk through and it will first render it, and then it will create the PDF for it. And so by doing that, it goes through and does them both twice, which means their rendering time is going to be within 1 minute of each other. Does that make sense? I mean, sort of. The idea basically here is that I couldn't get at this sort of stuff nearly as efficiently without these anti-joins and semi-joins, okay? So I got some error here in week 7, part 2, because I haven't actually modified those slides yet. So that's fine, I'm not worried about that. But this script is currently posted in the repo, so you can look at this if you want, you can play with it, you can modify it, you can do whatever you want. It's not gonna affect my version of it, right? This is a fairly complicated example, but it's a real example of where anti-join and semi-join are extremely helpful. Okay, so if you're struggling with that concept, I'd suggest trying to walk through this script a little more. Any questions on that before I move on? Okay. And part of the reason I mentioned that is because I'm through grading about half of your homeworks, not all of them, of course, but there's been quite a few examples of semi-joins that are sort of manufactured. And that's okay, totally okay for the homework. And it's sort of manufactured in part because I'm saying do a semi-join. And it's not like, here's a really perfect use case for a semi-join. So that's the other reason I wanted to show that. All right, so final thing, we're going to reproduce this plot. Okay, so I have my D, my data that I joined. And I'm just going to filter where the assessment type is TMA, right? Then I'm going to group by highest education, final result, and gender, and summarize to compute the mean score for those. Okay, so that looks like that. Then I'm going to mutate this so that highest education and final result are both factors ordered according to the mean score. Okay, so that's not going to change what the structure of it looks like at all, but you can see these are now factors. And then I'm going to just rename gender to be uppercase. Okay, don't have to do that. You could do that through ggplot too, but that's what I did. Okay, now we have our plot data, and it just looks like this, right? And we're going to put mean score on the x-axis, highest education on the y-axis, and then we're going to add geom line. I made it gray 40. Okay, it looks like this. And then I'm going to add my points on there. I say color equals gender, right? And I get something that looks like this. Let me switch my share here. Hang on. Need to add a share is what I need to do. Okay. Can you see that one? Can you see this or no?
No, we just still see what's in plots. We don't see your zoomed plot.
I don't know why. I'm not sure how to fix that. Oh, there we go. Does that work?
Got it there.
Got it?
There it is.
Okay. All right.
Yep.
So this is where I'm at now. Still not there. So I'm going to come back here and do facet wrap by final result. Notice I specify incall equals 1. That gets us here. It's rather large, but okay. So a little big, but otherwise fine. Oops. Okay, and then now I'm going to change the colors. So I say scale color brewer equals paired. Many of you used specific color palettes. That's fine. I just used a paired color palette from scale color brewer, and then I add my labs on at the end. And you can see it's still like a little bit big. I had it that size for the website, but okay. Then for the extra credit, the extra credit was basically this same plot, but instead of having just these points colored different, we wanted to actually have the line colored different according to which group had the higher mean, right? And so what I do here is I take my PD, my plot data, and I'm going to pivot wider, okay? So I'm going to take the names from this gender column, and I'm going to fill those columns with the mean score, okay? So that looks like this, right? Then from there, I'm just going to create a new column that says if else, if female is greater than male, then call it female, otherwise call it male. That looks like that, okay? And then we're going to pivot longer again, take the F and M column, put them to a new column called gender, and move those values to mean score, okay? So this basically moves it back to exactly how it was, but now we have this new column called higher group, okay? Then I'm going to rename gender, or I'm going to recode gender rather. So F becomes female and M becomes male. All right. Now from here, it's fairly straightforward. It's basically the same plot, but on this line part, we say AES color equals higher group. All right. And then down here, I have scale color brewer and I have scale fill brewer because we have fill for gender and color for higher group, okay? And then there we are. Questions on any of that? Okay. A few other things I wanted to mention. first, we are currently exactly 2 weeks away from when the draft of your final project is due. And so that probably feels really fast. That's just how the term goes. I don't know what to tell you. So you should have something on GitHub by this point. If you don't, you should probably make that a priority to do that as soon as possible. Okay. I hope homework 2 will not be too arduous. You will basically need this lecture that we're going through today to do it, but it hopefully shouldn't be too terribly bad. All right. So if you feel like you're starting to run out of time, let me know. But you can always push off homework 2 to even week 10, right? But you can't push off the final project. So do prioritize that. You need to have in 2 weeks, you need to have a repo that houses a draft of your final project that you can share for peer review. Okay, so that's one thing. The other thing I wanted to mention is just this order of topics. So on Monday, we're going to have Akila come and give us a guest lecture on dashboards. Akila created a great dashboard when she took this class, and so she'll hopefully share with you that. But she needs to do some teaching for her program, so this is, I talked to her and this is what she wanted to do. So, so that'll be great. And then we're going to talk about websites, all right? But and so when we're thinking about the final project, right, this is like the end goal. You need to have it in one of these 2 formats or a different format. There's others that I outlined in the syllabus, right, that you could have it in, but most people go in one of these 2 formats, either a dashboard or a website, right? And then in week 8, I'm going to flip the topics here, okay? So I'm going to take what we were going to talk about here and put it here. So we'll talk about tables and fonts on the 22nd, and we'll talk about customizing web pages on the 24th. And part of that is because this is needed for homework 2, which is due here. So I don't know what I was thinking there. But also this is, I think, just not as important as this is. And so we have this loose ends and review day here before our final presentations. And so if we end up pushing some of this down, this customizing web pages down into this area, then I'm comfortable with that. All right, because we still have a lot to cover even today that I know we're not going to get through all of it. Okay, so I'm going to flip those 2. Otherwise, like I said, you can push off homework 2 if you need to, but that draft is due in 2 weeks. Okay? Questions on that at all? All right. So before we do the data viz in the wild, I'm going to finish up the slides from last week or from Monday. Then we'll do our data viz in the wild, and then we'll actually fully switch topics. Okay? Are we ready for the slides though? Does anybody have any questions or comments or anything that you want to talk about first? Okay. All right, here we go. Okay, so I'm going to talk about ggforce rather quickly here. I'm basically going to talk about one thing and then sort of a variant of the same thing through ggtext very quickly, and then that'll be it. Okay. I'll mention themes really quick too. So ggforce. ggforce is a add-on for ggplot that is developed by Thomas Lynn Peterson, who's one of the authors of ggplot, and does a lot of just incredible, amazing stuff. I think this package is really, really, really nice. And these parts is probably my favorite part. So geomark rect makes a rectangle, circle, ellipse, or hole. And so I'll illustrate what these are. Here, I'm loading the Palmer penguins dataset, which just has some data on 3 different kinds of penguins, then ggforce. And we take the penguins data and we drop NA, right? The reason is because this function, geomark ellipse, and all of them actually cannot take missing data. Okay, so it has to do some calculations and it can't take missing data. So if we wanted to be a little more careful about this, we could say drop NA from build length, build depth, and species, right? And then if we had missing data on any other rows, those would not be dropped because these are the only ones that are used in the plot, right? But I'm just saying whatever, let's just drop NAs altogether. Then we add geomark ellipse, and we just specify the group and the label as species. So remember, we were talking about annotations to plots, right? Then we say geopoint, and then this chord Cartesian is just a different way to specify the limits of the x and the y. I mean, there's other things you can pass to chord Cartesian here also, but I'm just extending the axes a little bit. And we end up with something that looks like this, okay? So very quickly, we've able to basically circle the 3 groups and show where they're at. And the thing that is nice about this is that now I can add this guide's color equals none, right? So basically I'm removing the legend here because I'm annotating it with these ellipses, okay? So in cases where you have the groups that are really well defined like this, this is super nice. The other thing that is fairly common for this type of thing is to limit it to a specific group. Okay, so here I'm saying, okay, geomark ellipse, for the data, I'm just going to filter where species equals gen2. Okay, then I get an ellipse just for gen2. Okay, so you can imagine if you had a group, if you had a scatter plot like this, and you were trying to show just kids who are in tier 1, right, within a response to intervention framework or something like that, you could just limit the data to just tier 1, and then this would draw a circle around that group, or an ellipse rather. The other thing that you can do that is sort of interesting is use, instead of geomark ellipse, use geomark hole, okay? And so here I'm doing all the same stuff. I've just switched mark ellipse to mark hole. This does require the concave man package, so you'll have to install that too. But then you get something that looks like this, right? And so you could do this for multiple groups again, but this is probably best used for 1 group, maybe 2 groups, all right? You can also notice there's sort of like this expansion around it. So, and that was actually probably a little more evident here, that this expands quite a ways around the thing. So you can change that by changing the expand argument. In this case, I'm changing it to 1 millimeter. By default, it's 5 millimeters, I think. And then we get a little tighter. But notice now we've got a couple of points that are actually outside. So maybe 2 millimeters would have been better. All right. You can also add more in-depth annotations by adding this additional description argument. So in this case, I'm just saying, okay, if penguins is not equal to gen2, then do nothing. But if it is equal to gen2, then have this long thing. Yes, I think you're good. Sorry, now my daughter's asking about the broken internet at our house. So then we go here, and this is all just the same as before, but now we say description is equal to DESC, right? Which is what I called this thing back here, right? I'm creating a new variable called DESC. Then I also changed the color of it. And we get something that looks like this. Okay, so this is like now a lot of information about this thing. And notice it's covering up some of the other points, so this might not be ideal. But you can also extend that this part here, the connector thing, you could extend that out further or whatever. So it's just a nice way to include additional annotations. Okay. Similarly, we can use ggtext to do basically the same thing. So I create this table that has that has a label. Okay. And then I'm just going to add it with ggtext geom text box. Say the label is equal to lab and the data is equal to text box. And then it ends up right here. Notice I have build length and build depth. Those are the X and Y, right? So I just put them at where I want this thing to occur. So this is more of like a global plot level annotation thing versus like annotate these specific points, but it's kind of similar vein. You could also change the background and the color and all of that stuff on that one as well. Okay. Last bit, this is a really nice walkthrough, I think, of a lot of this sort of stuff. So check that out. It's a blog post and it's not coming up, so forget it. But it walks through a bunch of that GG4 sort of stuff and a bunch of other sorts of things like that. Okay. I'm going to basically skip over this because we're now even shorter on time than we were before. But basically, you can create a bunch of different themes. GG themes is a good place to start. Let's see if this works. Yeah, so here's a bunch of different themes that come with it. They have color palettes and things too. So you can take a look through this and see if there's any that you like. I make a joke about Stata in economics conferences. You could go fit in there. BBC also has their own style. So here's an example of some of their plots. They have a little cookbook thing that they use too. So I think they look really nice. Notice they're using annotations very heavily. Also, that's a really good thing, but can be difficult. I don't know if they have functions that help you with that. There's a repo and things to help you out with if you like their style as well. And again, I think I mentioned this, but the BBC literally creates their graphics like 98% in ggplot, which is pretty neat. And then they open sourced all of their stuff for doing that. So it's pretty neat. GG Theme Assist I've mentioned before. It's kind of fun, and then theme for everything else. So this is an example where from lab 3, right, I created a basic plot. It ends up looking like this. This is pretty close to what I want, but then I port that into GG Theme Assist and just start playing around, and I get something that looks like this. Like this is a ton of code that I wouldn't probably write on my own, right? But then that final plot ends up looking like this. One thing I will mention about GG Theme Assist though is it does not write your code very prettily, right? It's not really a word, but it will do like a bunch of themes and then they end up like all messed up. So I like to just have theme and then have all of your arguments there in one theme, and then make sure that you have returns and things like that. Okay, so we're going to talk about visualizing uncertainty now for the rest of the day. Homework 2 is officially posted, and it's technically assigned today, but like I said, I would focus on your final project unless you've made a lot of progress on that. It's technically due in 2 weeks, but so is your first draft of your final project. So that's higher priority. Okay, I'm sorry that part all went super fast. Are you all okay if we shift Raleigh and Maggie? Can we push you to next week? Oh, yeah, Maggie, you already went, right?
I already went.
Yeah. So Raleigh, are you okay with pushing to next week?
That's okay.
All right. That'll give us more time to actually focus on the rest of this content. Okay, so uncertainty. I'm going to take a deep breath here first for a second. Do we have any questions or anything? I need to slow the pace down now. Don't need to go a million miles an hour. Questions, comments on any of that before we switch gears rather abruptly here? Okay. So just to summarize, plot annotations are super, super helpful for reducing cognitive load. They can really make plots more approachable and help explain what's going on in the plot. They can also often be a lot more work. It's a lot more tweaking and manual editing to try to get them to work. So this is where I would say, I mentioned this before, but this is not something that you would do for exploratory plots. It's only when you've gotten to a plot where you're ready to go, you want to use this plot for a publication to communicate as effectively as possible with your audience. And I would argue that plot annotations are a useful tool regardless of your audience, right? Whether it's a scientific audience or whether it's a general public audience. So now we're going to move on to talking about visualizing uncertainty. Okay, and this is a pretty complicated topic. There are people where their entire specialization is in uncertainty and the ways that we visualize and interpret uncertainty in estimates. Okay, so we're going to talk about common ways of visualizing uncertainty, and then how to implement it in ggplot, and also framing uncertainties as relative frequencies. Okay, this is becoming more commonplace, and you see 538 do this a lot. So rather than saying, there's a 66% chance of something happening, they would say 2 out of every 3 times we would expect this to happen, or something like that, right? That helps us to understand it quite a bit better than just raw probabilities. We'll talk about non-discrete probabilities and understanding AUC calculations a little bit. That's not really that big of a thing. Understanding standard errors, and specifically a few non-standard ways of visualizing standard errors. And we'll briefly talk about something called HOPS, which stands for hypothetical outcomes plots. Okay, so the learning objectives for this lecture, I would say today, except we're already more than halfway through, is to understand there are lots of different ways to visualize uncertainty, and that the best method may often be non-standard, okay? Because the standard ways are usually just error bars, and they're okay, but we tend to not interpret them well. Understand how to implement basic methods in ggplot, and then resources to help you learn more about some of the more advanced methods. Okay, primary problem is this, right? We see a point on a plot, and we interpret that. We see that point there, and we interpret that as the value, which is very logical, right? That's where the point is. That's what it means. The problem is that's not actually always true, because there's uncertainty around that point. That point we have plotted there, but that doesn't mean for sure, without a doubt, that is 100% truth. That's where that point is. That's where it belongs, right? So let's have Dr. K explain.
I'd like to start with is this question, which is what happens when we ignore uncertainty? This is one of my favorite examples of an uncertainty visualization. This is from a scientific paper. This is actually from recommendations for how scientific papers should be written. A mixed design ANOVA with sex of face as a within subject factor and self-rated attractiveness and oral contraceptive use as between subject factors revealed a main effect of sex of face, F of 1, 1276 equals 1372, P of less than 0.00, no thanks. So an alternative to this might be something like a regression coefficient table. You have essentially the same information there. The standard error is in brackets, and there's probably some asterisks for p-values, although that's really not very great either. So you might line up all of your coefficients and do a coefficient plot and slap some confidence intervals on there. Essentially, the same information is being communicated by these two presentations. You may even go a little bit further and do something like add a likelihood or a Bayesian posterior on top of that. So that's trying to give you a sense, a greater sense of the fidelity, or a greater fidelity in the sense of what the uncertainty in that estimate is, though. You still might ask the question, how easy is it to ignore the uncertainty? And I would argue very, so I could look at that number or that dot or that other dot and simply take those as the estimates and ignore the uncertainty. This contributes to what statistician Frank Harrell likes to call dichotomania, the unending ability of human beings to dichotomize things and ignore uncertainty. So what happens is I take all of these intervals, well, I won't try a laser pointer, or I can do it up here. I'll take all of these intervals that didn't overlap 0, and I'll publish those, and I won't publish that one, and then we get publication bias. So this is a problem. We talked a little bit about elections yesterday, and I think one of my favorite examples of dichotomania comes from elections. So these are probabilistic predictions of Trump's chance of winning the election in 2016 from 3 different poll aggregators. So 538 gave him a 28% chance, the Upshot gave him a 15% chance, and Huffington Post gave him a 2% chance. A lot of people got angry at these poll aggregators because they were surprised, and also for other reasons, obviously, but I think surprise was a component of it. And part of that is that you see that 28% and you're quite content to round it down to 0. So let me show you something else. This is called a risk communication theater. The idea here is I give you a ticket to a random seat in this theater. The seats are colored black in proportion to the chance of Trump's winning the election. I hope you might agree with me that you would be a little less surprised to end up in a black seat here than when I just told you the chance was 28%.
Right, that's where I wanted to get to. This is, to me, a really powerful example. You say 28% chance of Trump winning the election. And many of us, most of us, I would argue, are, as he said, very content to round that down to 0. But if you look at this plot here, 4, 5, 38, it makes it much more clear that 28% is not 0, right? If you have a random ticket to this theater, there's actually a fairly decent chance you're going to end up in a black seat, right? And so that's the point of much of this lecture, okay? So,
hey, Daniel.
Yep.
I have like a devil's advocate question with that plot, especially on the left there. I feel like our brains, and I have no evidence for this, but like based on some of the stuff we talked about in the color lecture and stuff like that, I feel like this in my brain, if I were asked to guess the amount, would guess a lot higher than 28. And I don't think I'm alone in that. With like naive sorting, I feel like this is honestly miscommunicating or like distorting perception. What do you think about that?
So I disagree, I guess, because this is literally 28% of the squares, right? So so I will show you a different way to do this, maybe that might get at what you're saying a little bit more clear, because you keep the whole thing as just a square and then just shade 28% of the squares. Although then you end up with rounding bias, right? Because if you have 10 squares, you would shade 3 of them. But yes, I agree that this looks like more than 28%, but I think that's part of the point, right? Is that 28% is actually more than we think of. We think of 28% as very small, but it's more than 1 out of every 4, right? So more than 1 out of every 4 seats is colored black there. And if you think of it again in terms of those relative frequencies like that, then that makes it more obvious that this is not 0. And I think we are very content to round it to 0.
Okay, I see the benefit. I just also have like some other issues with this because there are other ways we can present data that are like what are in the data, but it doesn't look that way. Like,
yeah, well, I will tell
artifact.
you, there is a lot of research on these risk communication theaters, and they are much more accurate at people assessing risk, and they're actually used in things like helping doctors make decisions about diagnoses, because they'll get some number, and rather than reporting the probability, they'll get a visualization like this in addition to a relative frequency, and then they'll assess people's decisions that they make, and they're much better at making decisions when they have something like this to look at than if they just have a probability.
Okay, thank you.
And we'll get back to that lecture at the end. I would recommend watching this entire lecture if you're interested. Matthew Kay, his entire area of research is in uncertainty visualization. This is actually a keynote he delivered at a conference, the Tapestry Conference. He's at the University of Michigan. I think he's incredibly skilled, and his research is really interesting to me. So as I've sort of already said, we're not very good at understanding probabilities as humans. We're just not. We regularly round things to 100% or 0%, and we generally get worse as things move towards the tails. So how do we typically communicate uncertainty? We use error bars, right? This is what he talked about already, but those don't tend to work very well either. But it's still better than nothing, right? So we might want to know how to do this, because some of the more advanced methods are more difficult, and there's not as many tools out there for you to do this, and this is very expected in a lot of journals too. So it's still worth knowing how to do, right? So how do we do this? We use geom error bar. It requires a ymin and a ymax aesthetic, and you have to supply those values. So it will not calculate them for you, okay? If you want horizontal error bars instead of vertical error bars, you just use geom error bar H, okay? H for horizontal, and then you have xmin and xmax arguments. So here's a quick example. I'm using the MPG data set, grouping by manufacturer, computing the mean, then the standard error of the mean, which is just the standard deviation divided by the square root of n. And we get something that looks like this, okay? Now, if we want to actually create the error bars, we could do it like this, right? This code right there is probably the only bit that might be unfamiliar. And what this is doing is just pulling the value from a standard normal distribution at 0.025. So this is essentially negative 1.96, right? And this is 1.96, basically. But these are the exact values. So that's the only thing, okay? So this is plus a standard deviation, and this is minus a standard deviation, and we get something that looks like this, okay? Then we might want to add points to it. Notice I'm putting points on top of the error bars, not the other way around. This is a super common thing because you want to put your points on and then you want to add your error bars. But because ggplot adds things on top of each other, it looks awkward, I think, when you have a point, especially if they're different colors, and you've got the error bar, you'd have like a line through your point because your error bar is on top of it. So ideally, you put your error bars first and then put the points on top of that. Okay, this is all messed up down here. So maybe one thing we could do instead is use geom error bar H, flip the axes, and now we end up with something that looks like this. Okay, so that's fairly straightforward. Any questions on that? Okay, the other thing we might want to do is add error bars to like a bar chart. Okay, so here I'm doing some quick calculations again, and then we have a bar chart that looks like this. So four-wheel drive, front-wheel drive, rear-wheel drive, and then we're using position equals dodge to put the bars next to each other instead of on top of each other. All right, so now we want to add some error bars here. So the first thing we might do is say plus geom error bar, and then same sort of thing here, color equals gray 40. Well, then we end up with these, both of the error bars in the same spot. So that's wrong. And then you might look at this and say, oh, we forgot to dodge them. Okay, so PD, we'll make sure it's the same dodge for both of them. PD is 0.9, position now is PD instead of dodge, right? And then on this one, position equals PD. Well, it still didn't work, right? This is like a super common frustration. Like, what in the world is going on here? The issue is you have to specify the grouping factor, okay? So you could say color equals year because you have group is implied when you're saying fill here. So I guess you couldn't do color. But you can say fill equals year here, and it might work, I'm not sure. But when you specify a fill or a color, it implicitly implies the group as well. So instead, we're just going to say the group is equal to year, and now we get those on there. This is a funky looking graph to me. To me, this like sort of introduces this visual artifact where it looks like you have these panels here because this part is just like so prominent now because they butt right up against it. We also have a fairly large problem here, which is this is the proportion and our error bars go into the negative, right? So these are literally impossible values. So our uncertainty shouldn't extend that far. Our uncertainty should extend to 0, but not past 0 because that makes no sense. Those values are impossible, all right? So what we're going to do instead is say, okay, if this is less than 0, then just assign it 0. Otherwise, give me that, okay? And then the other thing I'm going to do because of that visual artifact I mentioned is just change the width to be 0.5, okay? And then the size, I'm just going to thicken them up a little bit. And that now we end up with something that looks like this. These are called, often called, oh shoot, what are they called? Dynamite plots, because it looks like a dynamite plunger. And people often put these behind the bars, so you only have one side of the uncertainty. These are not great. And in fact, some people really hate them. But it is a way to show uncertainty. All right. What is uncertainty? Okay, that's the another question that I think is worth coming back to, right? It is exactly what it sounds like. We're not certain, right? And I think we often want to be more certain than we actually are, but we're not 100% certain, and we need to communicate that uncertainty. We are nearly always uncertain about events that haven't occurred, right? I mean, I would say always, right? How can you possibly be certain about something that it has not yet occurred, right? But less sort of clear is that we're often regularly unsure about past events also. So this is just an example that Matthew K uses in his talk. But if we saw a car parked somewhere at 8 a.m. and then the next time we see it, it's gone, and we're looking at 2 p.m., then we know the car left somewhere between 8 a.m. and 2 p.m., but we're not certain about when, right? So that's uncertainty about a past event, and that's very much in line with what we do with research. We collect, say, data about people, but that instrument that we're using is not perfect. It's not a pure measure of whatever it is that we're estimating, and so therefore we have some error in those estimates. We quantify uncertainty using probabilities, but we frame those probabilities as relative frequencies when we're getting to the point of communication. Okay, so a single uncertainty. This is just the day of problems. Let me try pulling up my local file. Maybe I just didn't have that. There it is. All right. So this is now what I was talking about, Chris, where we have just a square, right? And this square has, in this case, I can't remember how many squares. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 100, right? 10 by 10. So this is 1% chance, 10% chance, 40% chance of rain, right? And so you could call this success and failure or whatever, right? This is essentially equivalent to what doctors use very regularly today in many settings to make decisions. So how do we make this with ggplot? And this is very similar to the risk theater, right? We just basically create a grid of values, and then we assign those values based on whatever probability we're trying to communicate. Okay, so I'm going to use this function called expand.grid. This is from base. There's other functions that are similar, but basically we have, if we say x is equal to 1 to 20 and y is equal to 1 to 20, then we get all the combinations. So x goes 1 to 20 while y is 1, then x goes 1 to 20 while y is 2, et cetera, until we get all the way x going 1 to 20 while y is 20. So we get every possible combination. Okay, so that's a grid of values. We can look at this grid with ggplot like this, right? We take ggplot, say the grid is the thing we want to look at. We're going to pass the x and the y and just use geom tile. Here I'm saying the color is gray 40 and the fill is white, so that's just to show the grid. I'm using theme void here as well, so we have nothing but the grid there. Okay. Now we have to create an occurrence rate. So for each sequence of x, we create a variable that has the given occurrence rate. So there's lots of different ways that we can do this. This is one potential way. okay? So let's say we want to show a 10% occurrence rate. We take the number of rows in the thing, right, in our grid, and we multiply it by 0.1, 10%, right? We get 40. Okay, then we're going to sample, we just set a seed so it's reproducible, the number of rows times our, with a proportion at our rate, right, which is going to be 40. So then we end up with these, and then we assign those here, okay? So here I have my grid. I'm just doing row names to column, so I'm creating a new thing here, row ID, and we're creating a new column here called event. And if the row ID is in the sample, then we're going to say yes, otherwise we're going to say no, okay? And we get something that looks like this, okay? So now I'm just same as before, but we say AES fill equals event. So this is just a random sample at our given rate, and we end up with this thing. We can and probably do want to customize this because this is sort of ugly, and I don't know how well those colors are going to work for color blindness. So what is a good way to do this, and again, there's more than one way, but what's a good way to do this is to take a color, and then we're going to lighten that color and desaturate it, and then we're going to use that color. Okay, so the two values are basically a lightened and desaturated version of that color, and then that color. Okay, and these values, how much you lighten it and how much you desaturate it, sort of depends on the color you're starting with. And then we want to use chord fixed probably, and then we end up with something that looks like this. Okay. You could switch the probability. You could vary the grid size. This is 10 by 10, right? This is 20 by 20, 30 by 30. When you're getting to this point, this is probably too many, and it gets hard to process. There's also this visual artifact of these little like black dots that come between these lines. So you could switch the lines to be from white to something else, and that might help, but you have to be careful that it doesn't clash with that. Okay, does that make sense? Questions on that? So again, this is for a single probability. You're trying to communicate like X% or whatever, right? And that's for a discrete probability. But for non-discrete probabilities, we want to do basically that same thing. We want to get at that relative frequency and basically being able to sort of compare by sort of counting one to the whole. But we can't really do that when we have a continuous distribution. So this is an example from like political science sort of thing, right? Let's say the blue party, this is the blue party, there's a blue party and the yellow party. Blue party has a 1% advantage, okay, a 1-point advantage. The margin of error on that, so this is our best estimate, right, 1 point, but the margin of error is 1.76, okay, so this is the distribution of that error. So who's going to win? Right? Who's going to win the election? Our best guess, right, would be that blue would win by 1 point. But there's obviously some uncertainty in this. And so what we might want to say is, okay, well, what's the chance that blue is going to win versus yellow, right? Or what's the chance that yellow is going to win versus blue? So we can do a bit of math on this. Our prior distribution, so it's actually 1.02, right? And then standard deviation of 0.9. So what's the chance the end result is below 0? We can actually calculate this exactly by doing something like this, okay? We're taking a sequence all the way from -5, so blue loses by 5 points, to +5, blue wins by 5 points, okay? And then we're taking we're computing the likelihood, which is which we can use with d norm, okay? And we're saying what's the likelihood of each of these points given a distribution that has a mean of 1.02 and a standard deviation of 0.9, okay? Here I've just taken that likelihood and I've plotted it. Okay, so I put it in a data frame and I've said X, this thing, and then likelihood. Okay, so here's exactly our distribution. All right, and what we're trying to calculate is this proportion, right? This portion of the whole. So what we want to do is integrate, right? We want to sum that area and compare that area to the rest of the area under the curve. Okay, so we can do that by integrating with, some calculus, and we say, okay, sim, this is our data frame where x is less than 0, called this zab, I don't know why, and then we just use a function to integrate under that curve. So here's our x, here's our likelihood, and we get 0.129. So there's about a 13% chance that yellow will win. Okay. More easily, we could also simulate and we'll get essentially the exact same answer. So here, I'm just going to randomly draw 1,000 observations from that distribution that I have. Okay. So going back here, right? This is the distribution I have. I'm going to just randomly draw 1,000 values over and over and over again. Then I'm just going to say, okay, well, how many of those are greater than 0? And then I'm going to divide that by 1,000, or not 1,000. I guess that's 10,000, 100,000, whatever. 1 with 5 zeros. My brain's not working right now. All right. And we see 13% of them are not greater than 0, which is the same as to say yellow has a 13% chance. Okay. So we can do this mathematically by integrating and getting exactly what is the proportion that is less than 0 relative to the entire proportion. Or we can just do it through simulation by randomly drawing from this distribution a whole bunch of times and then just counting how many of them are less than 0 or greater than 0. Either way, same thing. Okay. So that's what we're trying to get at, right? There's a 13% chance that yellow is going to win. So another way that we could do this, and I'm going to actually jump ahead for a second here, is we can create something that looks like this. Okay, so we have all of these points, like all of this area, all of this space, and we're discretizing that continuous space into these little balls. Okay, so in this case, and this is actually better, in this case, each ball in this visualization represents 5% of the total probability. And so this does represent some rounding, right? Because this would say, okay, blue, and I've flipped the colors here on accident, but blue would have a 15% chance of winning here, right? But this helps us by having this is essentially the same thing as the risk theater, right? You can quickly count the blues relative to the yellows. And so that's how we sort of take this continuous distribution and put it in a way that our brains are more able to quickly understand the true differences. Okay, so it's still a low likelihood, but you can see that it's not nothing either, right? It's, in this case, 3 out of however many that is, 20, I think. Yeah, 3 out of 20. Okay, so that last part was super fast, so we'll go over that more next time I lecture, which will not be Monday because Akila will be lecturing. It will be Wednesday, and we're going to have to push off some of this stuff to later. But we have that built-in fudge day, so that'll be fine. Sorry about the Zoom issues, etc. But that's where we'll stop today. Okay.